Hello, and welcome to my YouTube channel, Reading Little Blue Books, out loud, while stoned. In this video, we're going to do part 3 of Little Blue Book number 1003, titled, How to Think Logically, written by Leo Markin. And this Little Blue Book was copyrighted in 1926. So this is according to Leo Markin 100 years ago on how to think logically, which we are in dire need of in this world. But I digress. So we left off in chapter 2 in the Little Blue Book titled How to Think Logically. And here we go. Even though, psychologically speaking, an abstraction may be impossible, abstract terms are very useful to the logician, the mathematician, and the scientist. The early economist, taking up a term which seems to have been first employed by Plato, spoke of the economic man, meaning one to whom the laws of economics would fully apply. Recent students of economics have chosen to abandon this conception. Professor E.R.A. Siegelman defines the economic motive as the motive which impels every human being to satisfy his wants with the smallest possible effort, or which leads him to secure the most pleasure with the least pain. The economic man, he continues, is a complete abstraction. By the economic man is meant the human being dominated by the economic motive. Such a man, however, does not really exist. Consider the geometric abstraction of the point, that which is without magnitude. The diagrams in a textbook of geometry necessarily represent the point as a dot, which has actual, although small, dimensions. It is impossible to draw the picture of an abstraction. In a given figure, we may argue that the vertically opposite angles formed by the intersection of two straight lines are not equal. This would mean simply that the lines in the drawing are not absolutely straight. We are simply not skilled enough to realize in the concrete the requirements set up in the abstract. This is the point of the distinction made by common sense between theory and practice. What is right in theory is right in practice, but only so far as the conditions stated in the theory are actually reproduced in practice. An economic law which holds true of an economic man would not hold true of a man not dominated by the economic motive. To argue that what is true of the more extended use of a term is true of the less extended, or that what is true of the unqualified term is true of the term qualified, is to commit an error in reasoning known as the fallacy of accident. Though we should admit that lying is a sin, we need not call Mrs. Jones a sinner for telling a suspicious-looking vagabond that Mr. Jones is at home. The fallacy of accident would be committed by one who argued that murderers should be put to death, and that one who had slain another in self-defense should therefore be hanged. Once upon a time, people used to reason in just this way. The establishment of cities of refuge, where the involuntary slayer might be safe from the avenger of blood, is an important event in the history of penology. In the converse fallacy of accident, the argument is from the less extended to the more extended use of a term, from the term qualified to the same term unqualified. We sometimes hear people argue, all the Chinese I have seen are stupid laundrymen or waiters in chop suey restaurants. Therefore, it is absurd to talk of Chinese culture. Or, I had a neighbor who used to get drunk and beat his wife. Obviously, then, prohibition is a good thing. Or, I never get drunk in my life. I don't see any reason for the prohibition laws. Something like this crops up every once in a while in a letter from Constant Reader, or even in the wise reflections of a newspaper editor. I read that a fellow named Pagliacci murdered a bootlegger named Georgopoulos in Chicago. And yet people say that our immigration laws are too strict. We cannot fairly say that any quality belongs to a class because it is characteristic of a few individuals, or even of a majority of the individuals in that class. Let us suppose that 3/4 of the inhabitants of a certain district are criminals. We are not justified in putting all the inhabitants in the same prison. We have no right to argue that James Doe or Jenny Rowe, who lives in this district, is a criminal. This type of erroneous reasoning falls under the heading of the fallacy of division. It depends upon a confusion between the collective and the distributive use of a term. A collective term stands for a group. A distributive term stands for an individual in a group. Congress is a collective term. Congressman is a distributive. What is true about Congress is not necessarily true about any given congressman. What is true of the slum district may be altogether untrue of any given dweller in the district. The fallacy of composition, the converse of the fallacy of division, arises when inferences which may be true of a distributive term are applied to the collective. It is erroneous to argue that a bundle of sticks can easily be broken because each one taken separately is easy to break. Foreign shopkeepers are wont to commit the fallacy of division in arguing that since America is a rich country, any American tourist is rich and should be overcharged. For the tourist may, as we know, be an underpaid teacher or librarian who has gone hungry in order to save up enough money to pay the expense of a short European trip. The fallacies of figure of speech arise from confounding a statement made hyperbolically, metaphorically, allegorically, poetically, jestingly, with the literal meaning of the statement. He was a lion in the fray does not mean he changed into the form of a lion, then entered the battle. It does not always imply ferocity in the person so characterized, meaning perhaps no more than he was brave in the battle. As we have seen, many instances of fallacious reasoning arise from varying uses of terms. The very first step in most arguments, therefore, should be the defining of important terms. In a debate over the question resolved that the United States should enter the World Court or should enter the League of Nations, it would be essential to state clearly what sort of court or league was meant. It might, under some circumstances, be advisable to define the United States also. People are beginning to talk seriously of the United States of Europe. But general terms present the greater difficulty, not only in controversial matters, but in any exposition. Definitions are important. In defining a word or a term, it is usually necessary to show that what class it fits and how it is differentiated from other individuals in the class. To define is to mark out boundary lines. Therefore, we may speak of the expansion and intension of a term. Extension has to do with the total number of individuals which the term might include. All the qualities which it includes make up its intensions. In some cases, we may conveniently define a term by indicating its extension. A particular Jones family might be defined as Mr. and Mrs. Francis X. Jones and their son Frankie. The class into which a term falls is its genus, and distinguishing attribute or quality of a term is its difference. Any essential attribute or quality of a term is called its property. an attribute which is unessential to a term, but which may be characteristic of of the some of the individuals included in it, or of all the individuals so included, is known as an accident of the term. The genus of bread is food. The difference of bread is being made from flour or meal, then kneaded and baked. One of the properties of bread is being baked in a loaf. Wheaten is an accident of bread. But if we were to define wheaten bread, we should find wheaten to be the difference and bread to be the genus. Whenever we affirm or deny something about a term, we make use of some or all of the 5 heads of predictables: genus, species, difference, property, accident. This sentence will perhaps be clearer to the reader after he has seen how prepositions are stated in formal logic. It should now be possible, however, to pick out the 5 heads of predictables in the following sentence. Men are all more or less rational. They all have heads, and civilized men make a fairly efficient use of the brains therein contained. There are several ways in which definitions may be erroneous. A term may be included in the wrong genus. Thus, a whale might be defined as a kind of fish. The extension indicated may be too broad or too narrow. The famous antique definition of man as a 2-legged featherless animal seems to include a plucked fowl in the same class with Homo sapiens. A child might define candy as something good to eat, which definition would apply to ice cream, at least in addition. To define ink as a black writing fluid would be too narrow the definition by making use of an accident instead of a difference. In general, a term should be defined in words having a precise meaning which is known to the persons making use of the definition. The unknown should be explained in terms of the known. However, it is sometimes necessary to build up one definition upon another. That is, the student must learn the meaning of one term, after which this may be used in defining another. Terms are sometimes defined by similars, metaphors, and other forms of trope. To a child, a horse may seem a big dog, but obviously, we cannot learn precise extension and intension in this way. To an ignorant peasant, nevertheless, it may be more helpful to be told that a whale is a big fish than that it is a mammal. Big fish gives him an approximately correct impression. Mammal may give him none at all. A synonym is not a complete definition, but abbreviated forms of definition are often useful, even when accuracy is essential. The class or genus may already be understood, in which case it is sufficient to indicate the difference of the term defined. A good definition indicates precise boundaries. That's the end of chapter 2. We're going to continue on here. But first, a hydration break. This and all hydration breaks brought to you by my friend Maddie. Hydrate, Maddie. Cottonmouth is the enemy of all. Okay, on to the next chapter, and it is titled Induction. In organizing knowledge, our aim is to discover laws, statements of the relations between phenomena. In any system of knowledge, it is necessary to begin with general statements, which are taken for granted on the ground that they are innate or that they are self-evident. To the scientific reasoner, every axiom, every self-evident statement of relationship must prove true in experience or else be rejected. A postulate is the assumed possibility of constructing certain figures. The best known logical system constructed upon the foundation of axioms and postulates is the geometry of Euclid. A familiar axiom is this: things which are equal to the same thing are equal to one another. This appears true to us. We have found no case in which it does not hold. Hence, turning the page. Hence, we are content to let it stand as one of the foundation stones of the Euclidean system. Modern mathematicians have built up systems based on other postulates and axioms than these with which Euclid began. The axioms of logic are known as the laws of thought. The first of these is the law of identity. A thing is itself, not any other thing. It has common qualities, however, with every other thing with which it is associated in thought. Hence, we could not reason at all about a sui generis God, or about anything which is truly sui generis. If we say males or mammals, the two terms employed obviously have something in common. But if we declare that whales are not fishes, there is still some sort of identity between the two terms. The usual formula for the law of identity is A is A. The law of contradiction is expressed by the formula A is not non-A. This is tantamount to saying that a term can be defined and that it does not extend beyond the limits of its definition. Observe that the term non-A includes everything which is not included in A. This is supplemented by the law of excluded middle. Either A is B or A is not B. But A may be partially B, partially non-B. A may be both B and C if B and C are not contradictory. According to the law of sufficient cause, everything which exists has sufficient cause for being what it is. This is usually known as the law of sufficient reason, and as such has stated by the philosopher Leibniz, a cause is that which accompanies an effect unconditionally. We are wont to say that the cause produces the effect, but the exact nature of the connection is difficult to prove. A reason is the explanation or justification of the effect. Leibniz said, "Nothing occurs for which a person having sufficient knowledge might not be able to give a sufficient reason why it is as it is, and not otherwise." He was thinking chiefly of justifying the ways of God to men. Voltaire amusingly parodied the philosophy of Leibniz by declaring that men were given noses to provide places for resting their spectacles. But, aside from the theological dogmas of Leibniz, and from any question of teleology or design in nature, the law of sufficient cause is important. Scientists believe that a cause may be discovered for every effect, even if they do not formally advocate this view. They act on the assumption in their researches. If they do not think that God designed noses for spectacles, they believe that certain causes, which may be discovered, are responsible for the appearance of the nose on the face of mammals. The laws of thought are all laws of order. If these axioms are true, then all the phenomena about us are not in hopeless chaos. We may arrange them and discover laws about their connection. Is it possible that there are effects without causes? Probably not. But we cannot give and the word is completely gone from the page. We cannot give something ordinary conception is caused by God or some supernatural being. But let us suppose that we should be forced to believe in absolute miracles, in phenomena caused neither by natural effects nor by supernatural agents. We should not be able to bring these phenomena into our systems to explain them as we do effects which have a cause, known or unknown. We could not perform any logical manipulations with them. A law is simply a statement of the way in which phenomena behave. To assert even so much as that they must behave in this way is to pass from science to philosophy. Turning the page. Dun, 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 dun. They always, under the stated circumstances, do behave in precisely the indicated manner. If we should find a genuine exception, if we should discover that phenomena in any given instance behave in a way other than that indicated by an accepted principle, then we should need to renounce the principle. A law in science is something which is discovered, not established haphazardly. A false generalization has no claim to be called a law. Though scientists should believe in the truth of a general statement for centuries, it must be renounced or amended as soon as any flaw is discovered. To say that a heavy body falls because of gravitation is not, indeed, fully to explain it, but the phenomenon is thus brought into the system of mechanics. Is there any ultimate explanation? Apparently, science can produce none. When the theologians attempt to show how the laws of science are set into operation by a deity, perhaps they take some steps which are not entirely logical. Scientists, insofar as they are men of science and not something more, must, we are justified in saying, be content to show that relations of phenomena to accepted laws and the interrelations between these laws. In seeking ultimate reality, philosophers go beyond the explanations of the scientist. It may be noted, however, that there is no fixed line between science and philosophy. What was once a problem for metaphysicians may now be a field where physicists measure and weigh. Merely to explain a phenomenon in terms of a general principle, however, is seldom enough. When we see a man falling through the air without visible cause and ask why, we are not satisfied with Newton's law for an explanation. We want to know whether he dropped from a balloon, fell off a roof, or in some other manner came to drop through the atmosphere. According to the familiar story, a solicitous lady asked a little Boston girl how she fell, and was answered, vertically. But this, we may be sure, was not the explanation which the lady desired. General statements of relationship are very important, however. Thus, if one of our friends has caught a dangerous disease, it is important that we should know how the disease is transmitted. If we know this, we may take precautions to prevent our catching it ourselves. The knowledge of this relationship may also assist the physician who is trying to cure him. True, knowing what a certain microorganism has entered our friend's body does not in itself tell us how it came to enter and to cause his illness, but knowledge of the habits of the bacterium may help to explain even this. The possibility of successfully combating disease, which formerly were epidemic, has come about through the discovery of several scientific laws. How are general principles established? There are two important steps: guessing at the principle and establishing its truth. But first, there are preliminary processes: the conception of facts and their classification. Merely to classify is enough to point out certain relationships. To guess or to set up a hypothesis is to form an opinion from considerations which appear significant, but which are not conclusive. Thus, if we observe that certain objects grow larger every time they are heated, we may suppose that there is a causal connection between heat and the expansion of matter. The domestic animal which hears a certain call and thereupon runs up expecting to be fed has made a rudimentary sort of generalization, but the establishment of general principles. Okay. But the establishment of general principles, properly so called, depends upon the ability to use language, especially abstract language. The pig, as we believe, does not possess the ability to think. The sound produced, which has always produced the appearance of food, intended for me, will continue to have the same meaning. Certainly, it cannot think. There is a causal relation between the call and the appearance of food. Human beings can think in this fashion. To be sure, the generalizations they make do not always hold true. Many general statements are not laws, are not true statements of the manner in which phenomena are conditionally related. Some manner or verification, some sort of testing process is required before it can be determined whether or not the guess is true. Inductive thinking, reasoning from the individual to the general, from the concrete to the abstract, is no new thing. It certainly does not begin with John Stuart Mill or even with Francis Bacon. But these two men have done much to make clear the principles of inductive logic. When we deal with Mill's canons, we must remember that their author was not inventing new methods. He was only attempting to show how scientists and other exact reasoners had actually been making and testing generalizations. My elbow just hurts. Mill found that the greatest difficulty in connection with induction is that in some cases a single instance where two phenomena appear to be causally related is sufficient to make a complete valid induction, while in other cases a good many such instances, without any known exceptions, may be insufficient. It was the realization of this difficulty which led him to investigate the methods of establishing valid generalizations. The most obvious way of making a judgment which applies to all the members of a class is to show that it applies in each individual case. This method is known as that of perfect induction. By no other method can we be absolutely sure that we have attained an accurate result. Indeed, it is possible that we should overlook some member of the class which actually provides an exception to our generalization. Moreover, the method of complete enumeration does not ensure that all members of the class, at some future time, will possess that quality which is now found in each individual member. In other words, the method of perfect induction is decidedly imperfect in that it does not enable us to discover laws to establish unconditional relationships. The counting of individual cases, even if it be complete, cannot sufficiently test our generalizations. If we have set up the hypothesis that A and B are causally connected, we must suppose that A is always present whenever B is present, that A is always absent when B is absent, and that A and B vary together. Otherwise, there is no complete causal connection between the two. Let us suppose, for instance, that we have guessed that there can be no combustion without the presence of oxygen. We conduct experiments and we learn that in every case, when a stick of carbon or other substance burns, oxygen is present. When the oxygen is removed, no other condition being changed, the fire goes out. If, however, we find some other element which acts in the place of oxygen to make combustion possible, then we must modify our generalization. An understanding of the inductive methods is not in itself sufficient to enable one to establish true general relationships. First, there must be accurate perception, memory, turning of the page. Come on now. Okay, accurate perceptions, memory, classification. In any field of knowledge, there are certain matters of technique to be acquired. The jeweler sees properties in a gem presented for his appraisal, which the untrained person utterly fails to perceive. A geologist looking at rocks observes important differences and likenesses, which would entirely escape the unscientific person. Without full analysis of the data, an inference cannot properly be verified. Needless to say, even scientists, even trained reasoners, do not always perceive, do not always analyze, do not always draw inferences which are totally without error. But a person who is imbued with the scientific spirit does not hesitate to renounce his own hypothesis, which he is careful to consider as merely provisional explanations, when he discovers that they are in some manner less than statements of unconditional causal relationship. The first of Mill's methods is the inductive method of agreement. The canon or criterion of agreement is, in Mill's words, if two or more instances of the phenomenon under investigation have only one circumstance in common, the circumstance in which alone all the instances agree is the cause or effect of the given phenomenon. Suppose that a number of theaters of all conceivable sorts in cities and towns of all sizes, stages, in addition to varying programs, a Charleston contest, and all agree in doing much better than normal business. We are justified in supposing that the increased business is due in all cases to the contest. But we must be certain that the various instances have actually no more than the one important circumstance in common. The various Charleston contests might, for instance, have been held at a season especially favorable to good business in the theaters. In many scientific investigations, it is much more difficult than in the rather simple instance cited to be sure of complete analysis and to be certain that all relevant circumstances have been considered. In the good theatrical business, if the good theatrical business were due to a combination of Charleston contests and favorable weather, we should have an instance of the plurality of causes. As a matter of fact, we often find in searching causal relationships a combination of causes or effects which arise now from one cause, now from another. Therefore, it is seldom possible to feel that the truth of a generalization has been established by means of the canon of agreement. The canon of the inductive method of difference is as follows. If an instance in which the phenomenon under investigation occurs and an instance in which it does not occur have every circumstance in common save one, that one occurring only in the former, the circumstance in which alone the two instances differ is the effect or the cause, or an indispensable part of the cause of the phenomenon. This criterion depends upon the notion that whatever can be eliminated is not causally related to the phenomenon, just as the method of agreement depends on the idea that whatever cannot be eliminated is in fact causally related to the phenomenon in question. As an example of the use of the method of difference, let us consider a child that catches cold whenever it goes out into the wet street to play after the child is provided with rubbers and trained to wear them whenever the streets are wet. Its parents find that under otherwise identical conditions the child fails to catch cold. They conclude that the immunity of the child from catching cold depends upon its wearing rubbers. or boots, galoshes, whatever. In the application of this canon, too, it is necessary to guard against the supposition that one of several joint causes is the sole cause of a phenomenon. Mill realized this, as the qualifying phrase, or an indispensable part of the cause, indicates. It is necessary to consider that an ordinarily adequate cause may fail to produce the accustomed effect on account of the presence of a counter agent. There may be holes in the ordinary efficacious rubbers, which permit the child to get its feet wet and to catch cold, precisely as though it wore no rubbers at all. And I think we'll stop right there for part 3 of Little Blue Book, number 1003. Let me get my little marker so I don't lose my page. Of Little Blue Book, number 1003, titled How to Think Logically, written by Leo Markin, copyright 1926. Thanks for listening, and join me in part 4.